Hey guys, how is everybody doing this week? I'm ready for Thanksgiving break. Don't know about you, even though we just kind of had fall break, but ready for the next break. But before we get there, we are going to finish off the rest of this module. So this is Digestive System 1. Okay, all right, so let's go ahead and fill this out. Stuff moved around here. Okay, so the first one, the purpose, actually, let me get my pen going. Come on. All right. The purpose of the digestive system is to hydrolyze or break down food or food molecules using water. Okay. Ingestion occurs when we take food through our mouths, and digestion involves the breakdown of larger pieces into smaller pieces that can be acted upon by digestive enzymes. Okay, so then we have two different types of digestion, if I can say that word. We've got mechanical. Mechanical digestion is when the food, for instance, like when you're chewing. There's also some mechanics to digestion as far as the wave-like motions that happen in the digestive tract to push food through. And then we have chemical digestion when the foods are broken down through enzymes, chemical reactions. Okay. And then we've got movement. This is the peristalsis that I was telling you about, the contractions in the digestive tract that helps move the food down the line. And then we have absorption, when nutrients enter the blood. And then elimination, everything that can't be digested or utilized by the body is excreted. I can spell elimination. Okay, all right. So layers of GI tract, there's always questions on this on the final, or I'm sorry, on the exams. So be aware of that. You do need to know them. Okay, so they wanted you, to use 1 as being the insidemost layer and 5 being the outermost layer. So the lumen is first, followed by the mucosa. After that is the submucosa, and then the muscularis, and finally the serosa. Okay. All right. Okay. So let's start with this, my gosh, I'm not gonna be able to say digestive today. Digestive system by looking at the mouth, okay? This is where the mechanical and chemical digestion both start. So again, the mechanical components involve the tongue and teeth. The chemical part is a variety of different enzymes that are secreted in our saliva. And that comes from salivary glands. We have 3 pairs of those, which you can see in this diagram. One of the enzymes that's secreted here is something called salivary amylase. Remember that when you see ASE, you know you're usually looking at an enzyme, okay? So salivary amylase, and this is where starches start to break down, so are sugars. Or complex sugars, okay? So that's where this happens. So again, we've got the parotid gland, the submandibular, and the sublingual as far as the salivary glands. Have you ever thought about, like you just think about eating something super sour? Like I'm thinking about warheads right now. They still have warheads. They must. Warheads, little hard candies, and they're so sour. Like I'm already feeling it right there. If you think of something super sour, you probably will too. Coming from the parotid gland back there. So anyway, okay. Moving along. Hang on, let me get my. All right. Before I answer this lovely question today, we're going to go to the esophagus. So obviously after you chew, food gets sent down the esophagus, moves the mouth in, or moves the food from your mouth to your stomach. Peristalsis is one of the things that lets that happen. You kind of feel it when you swallow because you have the constriction, little rings, little muscles around your esophagus that push the food down to the stomach. Kind of repetitive. And just like the other types of peristalsis that we looked at on the other page, this is driven by the smooth muscle, meaning it's not something that we're consciously making happen. It's not something that we're thinking about like we do with skeletal muscle movement. Okay, so then we have, does this really show it? It doesn't. Like listening to my kids in the background while I'm writing. Okay, so at the base of the esophagus, right before it enters the stomach, we have, well, I guess it's kind of showing it right there. Okay, we have something called the lower esophageal sphincter. And it acts as a gate, kind of, that should be a one-way trip, one-way gate, letting the food push down from the esophagus into the stomach. You know that if you throw up, food is forced back up that sphincter, pushing it out the other direction, the way it's not supposed to normally go. But that blocks the esophagus from the stomach and keeps the stomach acids from moving back up the esophagus. So with heartburn and things like that, you usually have a kind of a leaky sphincter that allows some of the digestive enzymes and acids from the stomach to leak back up, okay? All right, question of the day. Should you pre-chew the food you feed your baby? Pre-mastication. Yes, that's exactly what it sounds like. And it's not regurgitation, which is what a lot of animals do as far as feeding their young. Pre-mastication just means literally what it says, that you've chewed the food, allowing the digestion process to happen or to start happening in your mouth through the use of the salivary amylase, and then you feed that, you take that out of your mouth before you swallow it, and you feed it to the child. There are still cultures in different parts of the world that do things this way. It can help with immunity, but at the same time, it also can allow for easier disease transfer. this isn't a topic that we really think about here in the States, and frankly, in many countries of the world, we don't, because we buy or make our own baby food. And baby food is kind of in like a pre-masticated consistency, right? There's no lumps, there's nothing hard in it, there's nothing chewy, there's no big pieces. Baby food kind of has that same texture. So if you want to go for the all natural way, go ahead. Chew that food before you feed it to your kid. I don't think I could. I know I couldn't have done it. I would have gagged. I would have thrown up. I'm just saying, I can deal with a lot of stuff as a mom, but not that. Okay, that was fun. Let's continue. Let's talk about the stomach. Okay, so the stomach is this extension of the esophagus, if you will. And again, we talked about the esophageal sphincter being there to separate the stomach from the esophagus and keep things from going the wrong direction, which is back up. So I have to move this. And again, when this is open, and it doesn't have to be open like gaping open, but if it's just open even a little bit, causes heartburn. Again, because of the acids that's being forced up. Okay, so if this here is the esophageal sphincter, then we have another sphincter that separates the stomach from the intestines. And that is called the pyloric sphincter. And it's right down there. Okay, so the stomach is gated, if you will, which makes sense because the pH of the stomach is very acidic. And you don't really want those stomach acids moving along to other parts of the digestive tract for obvious reasons, because it's an acid and it's there to break things down. Ulcerations of the stomach are where some of the inner protective mucosa has been damaged, injured through infection, or through the stomach acid eating through it, and the stomach acid continues to eat through those layers. So the inner lining of the stomach is super important in protecting us against all of that low pH. Okay, so the other thing the pyloric sphincter does, or another function, if you notice the stomach, at least in these images, which is fairly accurate, it looks kind of like a wonky shaped balloon, right? That's partially inflated. Well, that goes into a narrow neck of the intestines because the intestines aren't built to hold the volume in the same way that the stomach is. And so rather than the stomach dumping all of its contents immediately into the intestines, which it wouldn't be able to handle, the sphincter allows for small amounts of the stomach contents to move into the intestines at a time. Controlled flow. Okay, so now let's talk about some of the muscles we have going here. We've got this oblique layer in the muscularis. If you see this question on an exam, the oblique layer of muscle that's in the muscularis layer is only found in the stomach, okay? So it's a unique characteristic to the stomach. Okay, and it has a diagonal muscle orientation. That was an R, orientation. Okay. This allows the stomach to expand and contract depending on its contents. Okay. And also helps with more mechanical breakup of the food. So if you have muscle layers that are running, you know, this way-ish, then the oblique layer runs diagonal to that. So if you, what's a good example? I don't know what a good example is. For some odd reason, pantyhose comes to my mind. But basically, it's this stretch that doesn't just allow for kind of a vertical or horizontal stretch. It also allows for some additional expansion movement. That's what this oblique layer does. Okay. All right. So then we have, oh, and by the way, the fact that it has this oblique layer means that in the muscularis has 3 layers in the stomach instead of only 2. Okay. Gastric pits. These are found in the mucosa layer. And these pits lead to gastric glands. And the gastric glands secrete a couple of different things. We have something that's called gastric juice, which has hydrochloric acid in it. This hydrochloric acid kills most of the bacteria that our stomach would come in contact with inadvertently. Obviously, in cases of food poisoning and things like that, you can still have levels of bacteria. When I say levels, I mean number-wise, where you're just invaded by a large number of bacteria, and then that can overwhelm the immune system and the stomach. And you know, the hydrochloric acid is not enough to neutralize it when it's in those huge numbers. Got my blanket. Sit here with my blanket. Okay. Yeah. So kills most bacteria, but not all, in large numbers. Then we have pepsin. This is an enzyme, and it's one of those enzymes that kind of ends with your IN. Pepsin breaks down proteins. If you need help remembering, I don't know, maybe this isn't a connection for you, but we talked about macromolecules, we talked about peptide bonds holding together amino acids. So peptide, pepsin, protein. Okay. As far as absorption in the stomach, there's not a lot. There's a little bit, some water, some vitamins, alcohol. If you've been drinking, the stomach will take that. But overall, there's really not much absorption here. This has a chemical and mechanical function to start breaking down foods so that absorption can happen in the intestines. My dog is dreaming and making weird noises. My house is like a circus, isn't it? Maybe you guys don't hear as much as I think you do, but when I get back, And double check on parts of my lecture. I can hear the background with kids and animals and people and craziness. Okay, let's talk about small intestines. So the small intestines are small in that the diameter is not significantly large. However, we have about 18 feet of small intestines coiled up in our bodies. Yes, that's what I said, 18 feet. Okay, that's a lot of intestine. And then doesn't count the added footage we'll get from the large intestine. Okay, so small intestines, we have the rest of chemical digestion completed here. All alone, just writing. Being nosy because there's like a FedEx truck pulling up outside. When I record at night, it's so much easier because there's like no distractions and I can't see outside and the kids are in bed and usually the dog's asleep too. So daytime recording is so much more entertaining, isn't it? Okay, so to finish the chemical digestion in the small intestines, we have enzymes provided by the pancreas. Okay. So I just made that pancreas. Okay. So the pancreas then is going to supply the small intestines with everything that it needs to finish the chemical part of digestion. And those things include amylase. This is one of our ASE words. And if you remember, amylase helps to break down starches. We saw it first in the mouth. So I say digests, but this is an enzyme. So really it's breaking them down, okay? It's catalyzing the reaction to break down the carbohydrates from their big polymers into smaller monomers. Trypsin, it's one of our SIN enzymes, and this one digests proteins. So when it comes to enzymes, you have classes of enzymes, okay? So like you have proteases, and proteases are going to be the enzymes that digest proteins. And we've already looked at trypsin and pepsin, and there's a whole bunch. And then you have carbohydrases, and those are going to digest carbs. And again, you have different types of those. So you have these classes of enzymes, meaning that there's more than one type of enzyme that's going to break down a protein, more than one that breaks down carbs, okay? There's a broad range. Then we have sodium bicarbonate. And the sodium bicarbonate is going to be our neutralizer for the hydrochloric acid, the bits that make it through the stomach. And that's part of the mix of things that the stomach sends into the intestines. Come on, little pin, you can do it. And unlike the stomach, which is going to be then very acidic, the small intestines are actually a little bit basic because the HCl not only neutralizes, the sodium bicarbonate not only neutralizes the hydrochloric acid, but there's enough of it that it also makes the intestines a little basic. So you notice the word bicarbonate. This is something that you're going to find in a lot of different like stomach settler things that you can take, like Tums and stuff like that, because it neutralizes HCl. So it can help to neutralize higher levels of stomach acid to help settle your digestive system. Okay, What else? All right, so what does the small intestine absorb? I'm so glad you asked. Absorption. We have absorption taking place in the mucosa and the submucosal layers because these are the ones that have the villi, which are these little kind of see little hair-like projections. Kind of reminds you of cilia, if you remember from cellular motility, the little cilia, the hair-like projections that are on like your respiratory tract, things like that. 2 L's. I can't remember how you spell this word because I always want to put just one. It's not, there's 2 because I gotta check. 2 L's. Okay. And again, these are like hair-like or hair-like projections. And their job is to increase surface area for absorption. Okay, so enzymes contained within the lumen and within the membrane of the epithelium. All right, so let's take a look at that. We have our columnar epithelium that contain smaller versions of villi, the microvilli. Okay, so when it comes to absorption, remember that the lumen is the inside, the open cavity, if you will, of the intestine or of the space. And so that's where you're going to find the enzymes or within the membranes of the epithelium. And again, we have columnar epithelium that contain smaller versions of villi called microvilli. Okay. Track the digestive of carb from mouth to small intestine, essentially. Oakley. Just see my dog's backside. Oakley. Okers. Come here. What are you doing? Hi. Can you lay down for just a second? No. We're going to get through this. So let's say that you eat something that has carbs in it. You eat some bread. Obviously, mechanically, you're going to start digesting it in the mouth and chemically with the presence of the amylase. That's going to move through the esophagus, down through the esophageal sphincter into the stomach. The stomach with its HCl and more amylase is going to continue to digest the pieces of bread that you've eaten. From there, it's going to go through the pyloric sphincter, through the small intestines, where we have these components right here. And then we're going to have some more absorption of some of those components, like the carbs from the bread that have been broken down into the smaller sugar monomers through the villi and microvilli. She really wants out. Okay. Last page. Oakley, we're on the last page. You can wait. Come here. Come on. Come here. It's okay. Yeah. Hi. Hi. She's not happy with me, folks. Not happy. All right. Disorders of the digestive system. Lactose intolerance. So lactose is a sugar. It's a disaccharide, if you remember. So it's made out of 2 monosaccharide molecules, galactose and glucose. Lactose intolerance means that the person lacks lactase, which is the enzyme needed to break down lactose, okay? Lactase is one of our ASE membrane enzyme endings. Okay. I don't think I've ever really heard her make that noise before. She's really not happy with me. Absence of lactase. These would normally be found on the microvilli. Have you guys seen those videos of like huskies just laying in the hallway yelling? It cracks me up because huskies are so vocal. Well, so is my coonhound. She has much to say and has all kinds of different sounds to say them in. Okay, so without lactase in the system to break down the lactose, you have all of these unpleasant side effects: gas, bloating, and diarrhea. Sounds like a Pepto-Bismol commercial, okay? But this is because the lactose causes fluid retention. Okay, so instead of a lot of that water being absorbed, it gets contained in the lumen. Okay, so that's going to be the cause of a lot of the diarrhea problems. It's because the water is staying in the lumen rather than being absorbed because of the whole solute to solvent ratio thing. The water's trying to be where all the solute is to balance that out. 1 second. Guys, please let the dog out. Okay. Moving along. The gas, the bloating, and the cramps pretty much come because of the bacteria that end up breaking down the lactose. So without the lactase, you're kind of just letting the bacteria that's in your gut break down the lactose on its own, almost like a decomposition process. Does that sound pleasant? No, it does not. And so with something decomposing, if you will, in your gut, you have all of the byproducts of bacterial digestion. So you get the gas that the bacteria releases as it breaks down the lactose, and all the other fun things. This is why we should be glad that we have enzymes. Without them, everything that we ate would decompose in our stomachs until it's naturally broken down by bacteria. And as I may have pointed out in a previous lecture, you'd starve to death with food in your stomach because it wouldn't break it down fast enough for you to get nutrients to stay alive. Enzymes, the good choice. All right, so bacteria. All right. And so people can take a synthetic form of the enzyme like lactate, things like that, that can add lactase to the system. So if you take it before you eat something that has lactose in it, it can help with that. Don't know how effective it is. Not lactose intolerant. So I don't know. Maybe if you are, you can tell me if lactate works. Okay, then we have celiac disease. Celiac disease is lumped in here because it affects the digestive system, but this is actually an autoimmune disorder. And so as part of this disorder, the immune system reacts to gluten, which, as you know anymore, gluten is found in like everything. Originally, it's kind of something that you get out of foods that would have wheat in them, but since so much of it is now, so much of our foods are processed with different ingredients. Gluten is in all kinds of stuff. So what happens is the gluten binds to the intestinal wall. Intestinal wall. And that means the immune system attacks it. Immune system, I'm going to write right over the top of this, okay? Immune system attacks. On the top, you can see what it should look like normally, and you can see the very pronounced difference between a normal digestive tract here versus what happens with celiac disease. So it causes, well, you can see that the microvilli are gone in celiac disease. So it breaks down the microvilli, and then it causes pain, but also malnutrition, because the microvilli and the villi are where absorption happens. So while the immune system is only attacking the presence of gluten, or only responding to the presence of gluten, the microvilli are then destroyed, and it prevents them from absorbing almost everything, okay? So as you can imagine, this can cause malnutrition because the lining is so damaged that it can't absorb nutrients. We have diverticulosis. There's also diverticulitis, which one of them is like a chronic, more of a chronic condition, and one is kind of a flare-up. But in diverticulosis, portions of the mucosa layer actually end up kind of burrowing down into the interstitial layers. So if we have our mucosa layer, you know, through here, then you can see that it creates these pockets that push down into the layers in between. Like this is supposed to be one right here. And here's one, and here's one. And then those pockets allow bacteria to get trapped in them, because as the food is moving through the intestines, you know, there's bacteria mixed in with it. And even if it's just part of our natural bacteria that we have in our digestive system, anytime you get a large colony of bacteria in one place, you're going to have issues. And so they get into these little pockets and cause infection. I'm going to put that. I can't think of a word. I'll just. Okay. So again, this can cause infection, inflammation, and this is then what you can have is your flare-up of diverticulitis. Okay. Treatment, it varies depending on the severity of the diverticulosis, the frequency of infection due to diverticulitis, antibiotics usually to get an infection under control once it's started. And then frankly, the only real permanent solution is to go in and actually cut out the section of affected intestine. So like down here, if this is the section that's affected, right here, what they do, they go in for a bowel resection and they actually cut out the parts that have all the pockets, and then they reattach the ends of the healthy intestine. So like, you know, this would be reattached to this up here, and then you let that heal. So that's really the only way to deal with permanent solution. Other solutions can include dietary restrictions, things that have seeds in them, nuts, anything that can like go through the digestive tract that still is small but kind of solid. People can avoid that because it keeps it from getting stuck in those diverticuli. My mom actually had to have this surgery done a couple of years ago, and yeah, it can result in something called a colostomy if they can't resection the bowel, if they can't reattach one end to the other. Then they have to do something, like I said, called a colostomy, which basically filters waste through the outside and a bag that's attached. And that sounds about as pleasant as you'd expect. And it is about as pleasant as you'd expect. But anyway, there's some information on diverticulitis for you. All right, that's it. Made it through this lecture on the digestive tract, and I have another one coming to you very shortly because we haven't even done the large intestine yet. That's what the party is, you know. We gotta get through that part. Okay. See you soon.